Assalamualaikum and hello everyone. So in this video we're going to look at the calculation of relative atomic mass part 2. Okay, so previously we have looked for example 1 until 3 on page 3. Okay, so first and foremost what we're going to look at is actually for the calculation. There's actually two parts of it. So the first one is actually to determine the average atomic mass, where this is the formula sum of Kimi divided by sum of Ki. For the calculation of average atomic mass, there's actually a unit there. So for example, if your value is correct but then the unit is incorrect ataupun salah, so you still get 0 marks lah. Okay, so but then that is not the last step because that is only our average. So next we're going to calculate the relative atomic mass. So relative atomic mass ni, remember, it has no unit, so we have to divide by 1/12 times mass of one atom of 12 carbon to cancel out the unit. So sebab itulah kita kata the relative mass has no unit. So example 1 until 3, I believe you could do it yourself. The example is quite straightforward. Lagipun Miss explain for example 1. We already got our M and our Q. Okay, so now let's look for example 4. So example 4 ni dia lain sikit soalan dia lah. But then the calculation is still the same. Okay, so kita tengok dekat sini. Naturally occurring iridium is composed of two isotopes, 191 and 193, in the ratio of 5:8. So calculate the AR of IR. AR of IR. AR tu apa? AR tu is actually our relative atomic mass. Okay, so bila dia kata calculate the relative atomic mass, first and foremost we have to find our Q and M. Sebab nak tahu sum of Kimi divided by sum of Ki. Okay, so sebelum ni kita boleh nampak the Q is here, the Q is here, and the Q is here kan, and the mass is given sometimes dekat sini ataupun in your graph here. Okay, so let's look dekat sini. Okay, it's only in sentences, so how we're gonna find it out? So naturally dia ada bagi tahu dekat sini ada two isotope 191 dengan 193 in the ratio of 5:8. So which one is our Q, which one is our M? Okay, so remember that your M is actually your isotopic mass. So isotopic mass ni, ataupun kita kata isotope, ataupun sebelum ni kita kata isotope mutation kan, isotopic mass ni samalah juga dengan our nucleon number. So in this case, which one is our M? This is actually our M. Orang happy. 191 dengan 193. Okay, so dekat sini bila kita tengok, so this is actually our M1 and this is our M2. Okay, but then M kita dah cari. Okay, kan Kimi Ki, M dah cari. How about our Q? So Q tu maknanya we got the information from the ratio itself, 5:8. Okay, so macam mana kita nak buat ni? So what does it mean here? Kalau ratio ni senang, just to make it clear to you, so sini lah. So 191 iridium, ratio dia dengan, kalau misalnya buat bahagi pun boleh juga, 193 iridium is actually 5:8. So this is what it meant by this lah. Kalau bisa buat macam ni lagi nampak senang. So from here we can see that, so when the mass is actually 191, so our abundance tu is actually 5. Kalau mass kita adalah 193, then our mass is actually 8. So dekat sini I'm just going to label, this is my M1, maknanya 191 ni is actually my M1, 5 ni is actually my Q1, 193 is M2, here is my Q2. So daripada sini barulah kita boleh cari our sum of Kimi divided by sum of Ki. Okay, so how we gonna calculate it? Okay, so yang ini aci tak main satu dia macam ni je. So first one, average atomic mass. Okay, so just to be safe, write down the formula. Tapi yang ini tulis jugalah, kita budak baik. Sum of Kimi divided by sum of Ki. So Q kita, Q1 is actually 5, M1 is 191, plus dengan M1 kita, Q2 kita, 8, M2 kita 193, divided by our sum of Ki kita is actually 5 plus 8. So ini I'm just gonna AAM, ni pun AAM. So our average atomic mass, okay, so we get our value. Okay, remember, selagi it's not the final answer, just to be safe, take 4 decimal places. So when I calculate this, I will get 192.4 0.2308. Okay, so this is not complete yet, so dia adalah AMU. Okay, but then now next step is actually, this is only average atomic mass, we want the relative atomic mass. So for the relative atomic mass, I'm just going to label AR. It's actually 192.2308. Okay, again, previously for the video I have shown you to you kalau AMU. Kalau tak nak tulis pun, it's fine. So yang ini, for example 4 ni, I don't want to include AMU. So how to write it down? Dia akan jadi macam ni. Oops. Divide by 1/12 times 12 carbon. So kita punya relative atomic mass. So since this is the last step, so kat sini lah barulah I feel so it's safer for us to take to 2 decimal places. So the final answer is actually 192.23. Okay, so that is for example 4. So dia lain sikit dekat sini sebab you have to you must understand that sebenarnya isotopic mass dengan nuclear number tu is the same thing. And then dalam case ni abundance kita, it gives you in terms of ratio. So example 5, I believe you could try yourself. Tapi dekat sini, dia bagi dekat sini 3.127. Tapi tadi dia bagi 5 to 8 kan? Yang ini 3.127 sahaja. So dia samalah juga. Kalau 3.127 ni, maksud dia 3.127, ratio dia 2:1. Macam tu. Sebenarnya sebab kalau 2:1, tak perlu tulis pun tak apa. Kan ratio is not 20, it's actually ratio dia 3.127 for 35 chlorine. Yang 37 chlorine is actually 1. So dia samalah macam 5-8 ni. Okay, so yang ni you could try yourself. Nanti boleh submit sahaja. Okay, so for the third, so kita dah tengok setakat ni baru ada kita dah tengok 2 cases for the calculation. So first one ni kita dah calculate based on the information here, where it given you straight straight away lah our Q dengan M. So number question 4 and 5, in terms of ratio. So let's look here for question number 6. So question number 6, dia kata boron B has 2 isotopes. So 10 boron dengan 11 boron. So kat sini sepatutnya kamu kena tahulah, this is our M1, this is our M2. Okay, and then dia bagi the relative atomic mass of boron is 0.81. Calculate their percentage abundance. Okay, so dalam case ni sebelum ni dia dah bagi Q, dia bagi M. So cari relative atomic mass. For this case is actually quite dia kena terbalik pula. Maknanya dia dah bagi average atomic mass ataupun relative atomic mass. So kita kena cari kita punya Q. So sebab abundance ni is actually our Q. So kenalah cari Q1, Q2. Okay, so yang ini so how we gonna do it? Okay, so yang ini ada soalan, ada case of assumption. So kita tahu ada 2 spesies kan? So kita assume je dulu. Okay. Okay, so assume 10 boron ni adalah X%. Okay, so kenapa ada percent ni? Sebab percentage. So kalau tak ada percentage, tak ada masalah. Okay, so bila satu ni adalah X, how about another one? Takkan kita nak buat Y, takkan kita ada 2 unknown. Okay, so since this is percentage abundance, so kalau dia full dia adalah 100% kan? Okay, so sekarang ni bila one of the species adalah X, another one is 100 minus X. Okay, so kita assume 11 boron ni adalah 100 minus X. Okay, so kenapa ada 100 ni? Sebab bila kita kata percentage, hence it will be in percentage ni, the full mark dia. Macam biasalah kalau full mark 100%. Sebab tu lah ada percentage ni. So kat sini, kita tulis macam ni lah. Okay, so sekarang ni we have our unknown. So barulah kita boleh cari. Okay, so right now, kita tahu our value, we know that. So, contohnya dekat sini, Miss buat RAM sajalah. Okay. So, kita tahu the average atomic mass dia. Okay. Tahu the formula dia adalah average atomic mass adalah sum of key me divided by sum of key. Okay. So, Sini dia kata adalah relative atomic mass adalah 8.1. 10.81. So kalau average atomic mass dia sama juga. Tapi beza dia adalah dia punya unit saja tambah unit. Tapi dekat sini Miss nak tulis unit pun, ni Miss nak masukkan value sahaja. Sebab sebelum ni kita calculation, we do not include the unit, only the final answer sahaja we will include the unit itself. So average atomic mass, the relative dia adalah 10.81. Okay. So sekarang ni, okay. So kita tahu 10 boron is actually M1. So this is actually our Q1. Ni adalah Q1 kita. This is actually our Q2. Okay, so Q1 kita adalah X. So we're gonna take X. Okay, lepas tu first M1 kita adalah 10. Okay, pluskan dengan, okay, so sekarang ni Q2 kita adalah 100 minus X. So bila kita kata 100 minus X, so we have to write it down. So 100 minus X dengan, kat sini, our mass is actually 11. Okay, divide by sum of key. Okay, so sum of key ni, up to you lah sebenarnya. Kita buat je lah. I'm just gonna write down the full one. So kita tahu, sum of key kita, Q1 plus dengan Q2. So sebenarnya, X plus 100 minus X. Sebenarnya kalau tak tulis pun tak apa. Sebenarnya because we know that, okay, bila kita kata percentage abundance, maka total dia adalah 100. So yang ni pun samalah, X plus 100 minus X. Because all this one pun, pun per 100 juga. So jawapan dia pun 100 jugalah. Okay, so tak apa. So dekat sini, so we get, kalau Miss buat one by one, so here we got, here 10x plus dengan 110 minus 11x divide by 100. Okay, so sini kita tahu adalah 1081 10x plus 1100 minus 11x. So when we do rearrangement, then we will get our x is equal to 19. Okay, but that is not the final answer, sebab dia minta calculate the percentage abundance. Dia nak tahu Q. So tadi kita kata abundance of our Q. Okay, 10B ni abundance dia adalah X%. So we know now that X is actually 19. So 10 boron ni abundance dia adalah 19%. Okay, so itu baru 10 boron. 11 boron macam mana pula? Dia adalah 100. Dia adalah 100 minus X. So 100 minus X percent. So 100 minus 19% is equal to 81%. Okay, so that is the calculation. So dia macam susah sikit. Dia taklah susah sangat. Okay, so first and foremost, when you look at the question, tengok apa yang dia nak. Kalau relative atomic mass, dia straightforward. Kalau yang ini, kalau dia minta our Q, the percentage abundance is actually our Q. So what we're gonna do first kita assume satu tu adalah X. Another one, kita assume dia adalah 100 minus X. So sebab yang ni dia guna percentage abundance. So that's why I use 100. Kalau ni percentage abundance juga, pun kita guna the same concept. So it's okay if you be unsure, tengok balik. You could try it yourself. Example 7. Okay, so for example 8 dengan 9. So kita tengok, I'm just gonna go through macam tu je. Yang ni pun kamu buat sendiri. So dia bagi a sample of chlorine, dia bagi abundance, dia bagi juga this is actually our mass. So calculate the relative atomic mass of chlorine. So yang ni straightforward saja macam the previous question. And last one ni, a sample of chlorine consists of 2 isotopes and relative atomic mass is 35.5. Determine the percentage composition. So question 6, 7 and 9 tu is the same one. So if you're unsure, you should try yourself. If you have any problem, you could ask me. Okay, so that's it. The last of the calculation of relative atomic mass.